Hello and welcome back to another video on ChatGPT prompt engineering for developers. So what I'm going to do here is to make a quick recap of the entire course detail as well as all the code that I have saw and learned about it. So in here, right, I use a full form from OpenAI as well as Andrew Ng mentioned which is the co-founder of Coursera and founder of Deep Learning. So they show us how can we use LLM to build applications much more quickly using the OpenAI LLM API. We can quickly build applications and capability that can bring innovation, provide value in ways that were cost prohibitive, highly technical, and impossible before now. So this course will focus on how LLM works, how to engineering good prompts, how to write good prompts, as well as how to use LLM APIs so you can develop capability that extend your application in most common case like summarizing a user review for brevity, uh, expanding, so automatically generating emails or essays, transforming for translation or checking spelling and grammar, as well as inferring like sentiment classification and topic extractions, as well as looking at the principle of how you can write effective prompt, systematically engineering good prompting, and ultimately build a chatbot. So the first module, this introduction, was based on Andrew mentioned how, for example, there is a lot of articles out there talk about things like 30 prompts that everybody has to know. And this is oriented for ChatGPT web interface, which is often used by people for one-off tasks. But the power lies is on, as a developers, how we can use, for example, OpenAI API to develop applications using this LLM. And this is something that, for example, based on their and based on based on their AI fund company, where now he mentioned that he's a sister company of the deep learning to understand how they can do that. And in the development of LLMs, there are broadly two types of LLM, like base LLMs, where they predict what is the next most likely word based on training data that can come from different sources, whether are private source or from the internet. So for example, when you prompt things like once upon a time there was a magical unicorn, the model will likely to look to complete with that live in a magical forest with all her unicorn friends. However, when we prompt things like what is the capital of France, the model will likely to complete with what is the French population, what is the largest what is the French largest city? What is the currency of France? Because articles on the internet that was used for this model to be yeah, articles on the internet that was used for this model, they're likely to have questions about the country of France. So in contrast, there we have is the instruction tune LLM, that what it does is try to attempt or try to follow instructions. So when you prompt things like what is the capital of France, it will likely to complete with the capital of France is Paris. So the way how it works is by you start with an LLM, with a base LLM, you train them with a huge amount of data, and then you further training to tuning with inputs and outputs that attempts to follow instructions using refined techniques like human research, sorry, reinforcement learning with human feedback. The model uh, are more helpful, especially when you uh, ask questions, and people behind the scenes make the model to be honest, helpful, and heartless. So you will less likely to get problematic output or toxic ones. So you can think of this model as a person that is smart enough but doesn't know the detail. So provided the context is helpful. For example, when you ask for tell me more about Alan Turing, well, it is helpful to provide context. So, what you want to know about him? His scientific work, his personal life, his role in history, or something else, as well as the tonality. Okay? Like, you want this as a professional journalist or something more casual. So, then I look at the principles that are important, especially when you're going to interact with this LLM, right? Principles for writing good prompts, such as write clear and specific instructions, and several tactics that help you to follow this principle, like use delimiters to differentiate different parts of your inputs, such as triple backticks, triple quotes, triple dash, angle brackets, XML tags, and ask for structured data such as JSON and or HTML. Check whether the conditions is fulfilled to do the task, and check any assumptions that the model to complete the task, and provide example to the few shotting. So give the model a successful example to complete a task, and then let the model to perform the task. Okay. So the other principle is give the model time to think, quote quote. Meaning, well, much like a person when you ask to yeah, much like a person when you quest much like a person when you ask to solve a complex math problem without giving proper time, they will likely to give you a wrong answer. So to prevent this, so once you get an incorrect conclusion from the model, try to reframe that in a way that provide a series of steps or a change of reasoning. So for example, following is tactics like provide step to complete the task, or provide specific instruction to complete the task steps, or ask the model to figuring out its own solution before rushing to a conclusion. An example of this is like you have a student math problem, okay, and the math problem, so you ask the model, hey, figuring out the solution of this math problem, compare that with the student solutions, and ultimately give me an answer if the student solution is right or wrong. So based on that, now, well, then I look at the iterative approach, especially when you are developing front applications, when you are doing this process. So it's much like similar to the machine learning development where you have an idea and then you go and implement that, so to collect the data and the code, and then you check the results, okay? You analyze the experiments, figuring out what went wrong by doing this error analysis and repeat. But in the context of prompt engineering, sorry, yeah, but in the context of prompt engineering, it's much like, well, you have the idea, then you write the prompt by following is the principle, write clear and specific instructions, as well as give the model time to think. You figuring out why you don't get the desired output. It doesn't that doesn't mean that you wouldn't get the your desired result uh, on your first attempt, but it's less likely, you know. Even though you look at that, you're figuring out why you don't get the desired return or your desired output. You refine your prompt and repeat the process. Okay, so this, according to Andrew and G, this process is for single application or for application with one example, right? When they want to analyze this one example. However, for more mature applications, when you want to analyze is dozens of example, for them it is better to have metrics like what is the average and worst case performance, and from there uh, choose whether it's more feasible for a particular use case. So okay, that's actually great. Yeah, that's actually great. For Joe Rogan, okay. Yeah, guidelines, principles, and the iterative process. Okay. And then I look at the specific use case that we can use. So, so for example, we have summarizing, and this is great, especially because we don't have right now all the time that we would like to have to read things that we're interested. So these features or this feature can allow us to do that. So the web interface use this, right? And the prompt keyword or topics So prompts, keyword, or topics that you can use this is like, for example, summarizing or extract. And the use case for summarizing is, let's say you have an application, for example, an application that wants to help a lawyer to get an idea or to get a sense of what's in that text, what is in that uh, the, piece of paper or that document. So if the and optionally present a link or a button to dig in, and optionally presents a link or a button to dig in more if they wish. Okay, so that might be one particular use case. Okay, the other is inferring. All right, so with inferring, I saw full formation that you can think of all of these tasks where the model takes a text input and then performs some sort of analysis. And this could be uh, label extracting, name extracting, so to, or kind of understanding the text or that kind of things, right? So you can think of this anytime when you're looking at particular task, okay, summarizing, inferring, uh, among others, like transforming and yeah, like transforming. What is the other? Yeah, like transforming. Um, mhm. Yeah, so like transforming. Jesus, again, summarizing, inferring, transforming, and expanding. So you can think of this task where the model take a text of input and then perform some sort of analysis, whether it's kind of figuring out the sentiment of a text, extracting names, extracting label, that kind of thing. And Andrew mentioned something interesting here because in the traditional machine learning development or in the traditional machine learning workflow, okay, to, for example, do one of these tasks, extract the sentiment of a text, uh, you have is the sentiment, for example, extracting sentiment or extracting name, you have to deploy a separate model, meaning that you have is to collect the data model, train the model, and then figuring out where to deploy your model somewhere in the cloud. And this process it works pretty well, but it requires a lot of work to go through for each one of these tasks. So, for example, for sentiment classification, you have to create and deploy a separate model. For extracting names, you have to create a separate model. And one of these nice things about large language model is that you can do many tasks just by write a prompt and getting the results pretty quickly, giving tremendous speed in terms of application development and the simplicity that come with, because now you have one model, one API to do many different tasks. Okay, so I'm assuming here is that this instruction tune LLM, right, which are trained based on this a huge amount of data, right? Okay, so where they are trained based on this huge amount of data, uh, and then trained to tune in, yeah, and then train to tune into a with inputs and output to attempts to follow instruction. So based on this, right, and also it's because underneath the hood is using is NLM, man, natural language processing. Neurolinguistic programming is a neurolinguistic programming, no natural language process. What is natural language processing? Yeah, natural language processing refers to a branch of the computer science, and more specifically, the branch of artificial intelligence concerned with giving computers the ability to understand text and spoken words in much the same way human beings can. But for particular tasks, NLP tasks, speech recognition, speech, part of speech tagging, word sense disambiguation, name entity recognitions, co-reference resolutions, sentiment analysis, in natural language generation. But after all, is the NLP, this natural language processing, are is the ability to computers based on statistical model and train a huge amount of data. Okay, so based on a statistical model and huge amount of data. Okay, so based on that, mhm, so this natural language processing, even though I also saw the neural network specialization, where behind the scenes what it does is to, or underneath the hood, is perform statistical analysis. Mhm. It performs statistical analysis. Oh, did I lose my shit? Hmm. So based on this statistical analysis, or in this forecasting based on probabilities, okay, now this natural language processing, or this ability that the computer can understand human language or text and spoken words for particular task, you know, this is the ability to computer to understand text and spoken words the same way as human beings can for specific tasks. Speech recognition, part of speech tagging, word sense disambiguation, name entity recognition. This is for the marketing man. Name entity recognition, co-reference resolution. Is a task of identifying and when the two words refers to same entity. The most common example is determining the person or object to which a certain pronoun refers, she and Mary, but it can also involve identifying a metaphor or an idiom in the text. A large hairy person. Mm, Sentiment analysis and natural language generation. One of them is speech recognition and the other is natural language generation. So I will argue that this LLM or this large language model, okay, LLM, this large language model is a language model consisting of a neural network with many parameters, typically billions of weights and more, trained on large quantities or unlabeled text using self-supervising learning or semi-supervising learning. LLMs emerged around 2018 and perform well at a wide variety of tasks. These have shifted the focus of natural language processing research away from the previous paradigm of training a specialized supervised model for a specific task. Exactly. This has shifted the focus of natural language processing research away from the previous paradigm of training a specialized supervised model for a specific task. Because at the end of the day, this, what it does is to use is the reinforced learning technique. So the reinforced learning, reinforcement learning. Mhm. Because you have supervised learning and unsupervised learning. Supervised learning, exactly, they have supervised learning and unsupervised learning. The other levels in the supervised spectrums are reinforcement learning, where the machine is given only a performance score as a guidance as semi-supervised learning. Mm, Hope Field Network, Boltzmann machines. So in any case, so you have this supervised learning and unsupervised learning, and because this distinction, okay, is that this reinforced learning, after all, the one is just gonna play devil advocate here a little bit. Yeah, just going to play devil advocate a little bit here. The reason why the 13 colonists in the US increased their wealth was based on slave labor. And I'm gonna talk about morality. That's another topic and a very interesting one. Not for this, not for the scope of what I want to say. Which means is that recognize that after all, in order to improve your wealth, you have to rely on something. You have to rely on someone that can do that for you. Okay? A person or a machine. So if these machines can provide us ways in which we can focus is on the creative aspect of our life rather than the survival mode, which is after all important, okay, then we will like to have much more time to pursue that. So that's the utopia, right? That's the utopia. That's the utopia. So yeah, this is my reinforcement learning. So now this LLM, unlike this natural language processing, so when I look at this as the natural learning processing, or mathematical reasoning, this is the task that this large language model can perform, according to Wikipedia. So LLMs are purpose general models which excel at a wide range of tasks, as opposed to being trained for one specific task. Exactly. Such as sentiment analysis, name entity recognitions, or mathematical reasoning. So the skill with which they accomplish tasks and the range of tasks at which they are capable seems to be a function of the amount of research, data parameterized computer power devoted to them in a way that is not depend on the additional breakthrough in design. Mm. The skill with which they accomplish tasks and the range of tasks in which they are capable seems to be a function of the amount of research devoted to them in a way that is not depending on the additional breakthrough in design. Through training on simple tasks along the lines or predicting, yet through training on simple tasks along the lines of predicting the next word in a sentence, neural language model with sufficient training and parameter counts are found to capture much of the syntax of semantics of human language. In addition, large language models demonstrate considerable general knowledge about the world and are able to memorize a great quantity of fact during training. And you guys, uh, natural, natural app. This is different. Natural language processing. This is different. Natural language linguistic. Yeah, this is completely different. Natural language. Yeah, because this is different to this LLM. It's a language model. A language model is a probability distribution over a sequence of words. There's a probability of that. Recurring neuronal or transformer. Natural language processing and computer vision. The transformers, machine learning model. Is to distinguish by its adoptions of self-attention. Transformer was introduced in 2017 by the team of Google Brain and are increasingly becoming the model of choice for NLP problems. Mm. Replacing error models such as long short-term memory. Compared to error models, transformers are more amenable to parallelization, allowing training on large datasets. So long short-term memory. Common crawling can be fine too for a specific task. Gated error such as LSD and gate recording unit. Transformer model architecture. Mm. Okay, but this is dive deep too much in there. So what you wanna know about it? After all, it's like what you wanna know about this LLM, and especially it's because Andrew and G mentioned that if you want to extract sentiments, if you want to perform a particular task on a text, okay, such as extract the sentiment of a text, in the traditional machine learning workflow, you have to collect the data set, you have to collect the label data set, train the model, and then figuring out how to deploy that somewhere on the cloud. And this workflow works pretty well, but it turns out to be a very uh, in it turns out to be a lot of work to go through that process. So for tasks like sentiment classification and extracting names, extracting labels, you have to deploy a separate model. That's what happened for this LSTM, okay, or for doing a particular task. So for doing a particular task, okay, such as extracting the name uh, on a corpus of text, you have on a corpus of text you have to collect the labeled data sets, train the model, and then figuring out where and how to deploy that somewhere in the cloud. And this is just for one task. But now, one of the nice things of this LLM, which is follow a different approach, the architecture for this. Input embedding. Mm, mm. But now with this new architectures, that's right, all right. It is distinguished by its adoption of self-attention. By the adoption of self-attention. Self-attention has gained currency given its use in transformer-based large language model. It captures dependency between the different parts of a single sequence. The term self signals that attention is contained with a single structure. The model can capture dependency across the entire sequence without requiring fixed or sliding windows that consider only part of the sequence at a time. Self-attention is computationally efficient compared to recurring neural network, which process sequence sequentially. Transformer machine learning models scaled out production attention, perceiver, and components for query value. The TLDR for this, okay? The TLDR for this is that because doing, for example, doing one particular task, such as extracting names on a corpus of text, in the traditional machine learning workflow you have is to train the data set label, or to collect, in this case, is to collect the data set label, train the model, and then figuring out a way to deploy that somewhere in the cloud. Okay, and that could work pretty well, but it is a lot of work to go through. That could work pretty well, okay, but it's a lot of work to go through that process. And also for every task, such as sentiment or extracting names, you have to deploy different and a separate models. So one of the nice things about this large language model is that for many tasks like this, okay, so now it allows us to perform many tasks by just writing prompts and getting the results quickly, which give us tremendous speed in terms of applications development. That's right. That's right. So it will give us tremendous speed in the in terms of application development. Mhm. In terms of application development. In terms of application development. Okay. Yeah, in terms of application development. Uh, and also a simplicity, because we have one model that allows to do all of these tasks: summarizing, inferring, extracting, uh, expanding, and transforming by just writing a prompt following is the principles and the guidelines, and we can pretty quickly get the results. And the simplicity of this is because you have one model, one API to do many different tasks. So rather than figuring out how to train exactly, so rather than figuring out how to train and deploy a lot of different models. Mhm. Rather than figuring out how to train and deploy a lot of different models. Yeah, completely. So the prompt keywords or topics are sentiment. You indicate, well, provide me the sentiment, positive or negative. So identify type of emotions, information extractions like ident- um, uh, identify a company or product names, doing multiple tasks at once. So perform a sentiment classification and then extract the topic from that, and inferring topics. So for example, for the two, identify type of emotions, you can do that for example, to identify customer product reviews. Okay, or to extract topics and count. So to extract and count, to extract and count topics on a text, right? So okay, all right. So I think that I made this huge overview based on that is to gain a little bit more of perspective on what about what this LLM are, unlike this NLP, which is natural language processing, totally different, and unlike things like LSTM, long term, short, or following is this particular pattern, the recurring neural network, the RNN, all right? So to understand more about this. So that'll be all for this video. Take care. Bye bye.